In the previous video, we got familiar with the theoretical background of a tank level control system. In this video, we are learning how to make a tank level control simulation uh, using LabVIEW. This is the system we are going to design with LabVIEW. As said in the previous view, we need a transfer function with, for all these actually processes in this system. Let's go to, I'll show you again our block diagram of our control system. We should have something like this. Although in the program we are going to make, there will be some small differences, but I will explain about those afterwards. Okay, these are our assumption in this program. First of all, we assume that the transfer function of our pump is this. Also, the transfer function of the analog digital interface is this is in fact a proportional controller. We also assume that the transfer function of our sensor is also something like that. It means if, for example, the level of the tank is 80 meter, a voltage of 0.8 will pass through the sensor to the summation point. We also assume that our amplifier is able to amplify the input voltage up to 100 times. It means if we get, for example, 1 volt input into the amplifier, the output signal will be 100 volts. Yeah. We also talked about this. In order to select actually the maximum capacity of the pump, we have to know the maximum velocity of the output flow. Let's show. Sorry, let me show you the maximum velocity of here. Maximum actually drainage flow rate. Oh no. Okay, in this case, we assume that the maximum level of the water is 4 meter. Then therefore the maximum velocity is this, 8.94 meter per second. And we also assume that the diameter of the drainage pipe is around 20 centimeter. Yeah, 20 centimeter. Therefore, the maximum outgoing flow will be 281 liter per second. Therefore, the maximum capacity of our pump should be around and more than this number. Okay, at the end we want to have something like this. We want to have a PID controller so that we can control different parameters in this controller, for example proportional gain, integral time or derivative time. We want to have a gauge here showing the flow rate of our pump. We want to have a controller to give the set point of our of our tank. Here is our tank, simulated tank, and here is a graph showing the set point with the red line and also the current level of our tank, actually the output of our control system. Here we put also an LED showing in fact showing that if the pump is on or off. If the pump is on, the LED actually using this we are going to show how often the pump in our control system turned off and on in order to keep the water level at a certain level, actually to keep the water level constant, let's say, or at the desired and already at the desired level. I think it's hard to understand what is done in this program just using this picture. Therefore, we are going to make this program step by step. Just I have to make a pause and I continue